Hello Cobb Science. Today we're going to be learning all about rocks and landforms. Now for today's lesson, what I would like for you to do is go ahead and get out your lab journal and set it up just like this. As you see, we're going to have 3 different areas where you're going to be taking notes today. You're going to have a section that says igneous, metamorphic, and sedimentary. Now let's take a look at this video clip, which is going to teach us more about the Earth's rocks and landforms.
From space, our planet looks very peaceful. Clouds seem to move gently around Earth. But we know that Earth can also have some violent events. Earth is alive, always moving and changing, both on the surface and deep below. Even down here, Earth is never still. There have been a lot of big events in the distant past. Early Earth was pounded by meteors and asteroids. This has happened more recently too. This impact happened in the Chesapeake Bay 35 million years ago, long before humans evolved. Volcanoes are one of Earth's most dramatic surface events. You don't want to be near one of these. It's not just the fiery explosion or the terrifying materials that rush down a volcano's slopes. Large volcanoes also spew material high up into the atmosphere as a dark plume of fine powdery dust. This plume of dust can be so dense that it can sometimes block out the sun. And it can last a long time. The processes that cause a volcano to erupt begin down below. Here, the giant tectonic plates are pushed by forces inside the Earth. The plates shift and grind against each other. When one plate grinds under another plate, it causes mountains to form, such as the Rockies in northwestern America. A lot of big Earth events happen where we can't even see them, under oceans and seas. One is the formation of a mid-ocean ridge. Magma pushes through a place where plates are spreading apart. This also creates new ocean crust. Sometimes the crust below an ocean suddenly snaps into a new position. When this happens, it can cause a giant wave called a tsunami, very dangerous for people who live at the water's edge. In an earthquake, huge vibrations ripple in all directions. They roll across the surface and can damage buildings and injure people. On Earth's surface, many large events take place. Over very long periods of time, Earth has experienced big changes in temperature. In cold times, ice has advanced. This is what it might have looked like, though we've sped things up many times. As Earth warmed, the ice sheets melted. Much, much later, humans built New York City here. When ice melts, seawater levels rise. In its long history, Earth has seen many changes in sea levels. In Washington State, a long time ago, ice once formed a dam holding water back. When the dam broke, water then rushed over the land, changing it dramatically. Unlike events below Earth's surface, people can see big Earth events that result from the weather. Sometimes, weather conditions are extreme. Storms can produce serious flooding. Ice storms can stop us from getting around. Tornadoes can form suddenly and cause damage, even loss of life. But it is hurricanes that often produce the most dramatic events. These are massive storms which can be tracked by satellites. Here is what they look like in a computer simulation. Many big Earth events take place slowly over very long periods of time. Others can happen very quickly indeed. That is the nature of our planet. Our world may look peaceful, but its complex processes can result in many types of big events. From space, Earth does not look like a rocky planet. But if you take away its air, water, and all living things, Earth is just rocks and landforms. Every landform we see is made of rocky material. This is not just the solid rock we see in mountains and cliff faces. It is also the loose rock particles called sediments that cover valley floors and form large deltas, hills, and dunes. Mountaintops, desert sands, and all the layers underneath are made of rocks and rock materials. They may not seem to change much, but over time, sometimes very long periods of time, they are moved by wind, ice, and liquid water. Water plays a special role in changing rocks. As water moves downhill, it carries rock particles along, leaving some as sediment in river valleys. Other particles are carried into lakes and eventually into oceans. The particles settle on lake bottoms and ocean floors as deltas and layers of sediment. As time goes by, these layers of sediment get pressed together to become new sedimentary rock. We can sometimes clearly see the layers of sedimentary rock on exposed cliff faces. The journey taken by rocks does not stop there. Sometimes forces from inside Earth push sedimentary rock up, forcing it into mountains once again. This is all part of a process called the rock cycle. Not all rocks are sedimentary. This is igneous rock, and it has a different story to tell. Earth has many different types of igneous rocks. But all igneous rocks start with pressure and heat. It is pressure and heat from below Earth's crust that begins the story of igneous rocks. When the hot molten material called magma bursts through the surface as lava, it immediately begins to cool and form igneous rock. Igneous rock is also formed in oceans, where the crust spreads apart. Rising magma thickens the crust from below, forming new igneous rock on the seabed. Sometimes molten rock can cool below the surface, forming what geoscientists call intrusive igneous rock. A different type of rock forms when tectonic plates slowly but relentlessly crash into each other, pushing up mountains. As the mountains slowly rise, rock below gets heated, squeezed, and changed. This new material is called metamorphic rock. Metamorphic rocks can also form when magma rises through the crust and heats surrounding rocks. Metamorphic rock, like igneous rock and sedimentary rock, can be pushed up on Earth's surface, only to be worn away again, making new sediments that will one day become new rock. This is all part of Earth's ever-changing rock cycle. Humans have lived on planet Earth for a very long time. From early human civilization, people have used the materials of Earth's geosphere. For example, beginning in ancient times, humans have used rocks to make buildings and roads. They have taken minerals from Earth's crust to make tools, decorations, vehicles, weapons, and many other useful objects. humans have come to depend on resources from the geosphere for energy too. These resources include coal, known as the rock that burns, as well as oil and natural gas. These resources are known as fossil fuels because they formed from decaying plant and animal material over the span of millions of years. By refining and burning these fossil fuels, humans are able to fly planes, drive cars, heat their homes, and generate electricity that powers all kinds of devices. The geosphere provides many benefits to humans, not the least being the beauty of the landforms on the planet's surface. The geosphere also provides us with places to build homes, roads, bridges, and other structures, soil in which to grow food for humans and other animals, and surfaces that contain all the bodies of water in Earth's hydrosphere. While humans are very dependent upon the geosphere in many ways, they also have the challenge of living with hazards from the geosphere. These include volcanic eruptions, massive earthquakes, lahars, and landslides. By understanding how dynamic processes in Earth's geosphere produce hazards, humans can avoid the dangers and damage these hazards pose. One of the jobs of geoscientists is to watch for these hazards and to warn others, when possible, when they are about to occur. It is difficult to predict when earthquakes will happen, but geoscientists can help to pinpoint where they are likely to occur. This helps humans decide where it is safe to live and how to build things such as homes, schools, and businesses. The more we understand Earth's geosphere, the more we can live in harmony with the planet. It is our responsibility to use Earth's resources wisely and learn to adapt to Earth's many changes.